rational decision making, or knowing the future. We all want to know the future. We are desperate to know. Will the stock market go up or go down? Will the insurance pay my claim? What are next week's lotto numbers? Is what this Aussie is about to say going to be worth my time? Karl Popper called this our individual problem situation. The unique circumstances we find ourselves in by virtue of the fact we are individuals. We want to know the outcome. We want to know the future. And there are a lot of people out there who want to tell you what the future will be. Of course, we've always had soothsayers and fortune tellers. All cultures still do, and appeal to superstitious ways of tapping into a secret knowledge or way of knowing denied to the layperson. It was recently posited that the Oracle of Delphi, one of many advisors to Alexander the Great, was living in a cave whose fumes may just have been hallucinogenic. In any case, when the most powerful man in the world at the time asks you if he is divine, I guess you will answer in the affirmative, hallucinogen or not. But she, the Oracle of Delphi, didn't know that. She could not have known that. And this will be a theme of what I want to say to you today. There is much we cannot know, and most of that is yet to happen. Prediction, prophecy. Between these two ways of speaking about the future is a chasm of science, rationality, and reason broadly, and I want to show you that gap because I'm here to tell you it cannot be bridged. At the risk of stealing my conclusion almost before I have commenced, let me say this. There is a difference between knowing, which is to say, possessing a good explanation that allows one to calculate what is going to happen precisely when given the laws of physics. There's your prediction, versus lacking such knowledge or by knowing the very thing that creates this amazingly diverse world around us. And that's prophecy. Prophecy is ignoring how knowledge yet to be created is yet to affect the world. In short, it is ignoring what choices people, both individually and collectively as governments or businesses, will make. For deep reasons I will come to, those choices cannot be predicted before they are made. And when we talk choice, we mean decision. So in a real way, decision making, the very heart of what I'm talking to you about today, is knowledge creation, or choice creation. I'll say it again. Decision making is choice creation. But don't despair. While it might be true in most cases we cannot know the future, we can still have a commitment to rationality, to science, mathematics, epistemology, and yes, even intuition. Our own sense that something is or isn't a good idea, whether we can articulate why that is the case or not. None of this changes the fact we still want to know what the future will hold. Our decisions made moment to moment, from the minute to the momentous, depend upon us guessing about the future, hoping or dreading, as the case may be, what the outcome might be. But the problem is that while we know a lot, our knowledge is always finite, but our ignorance, well, that's infinite. The more we discover, the more we find out we do not know. We discover one planet orbiting a star. I'm still old enough to remember that back in 1992, I was in year 9 at school. And finally, a planet beyond our solar system had been found. Few doubted it would be eventually, but when it was, the old debates were over. We knew about one. But also, suddenly we knew there must be trillions upon trillions of planets out there we do not yet know the locations of, all because we discovered one. One discovery opened a window on a new infinity of ignorance, and astronomers have been engaged ever since in a rush to find more and more Earth-like planets that we know are out there, but are ignorant on exactly where. But we do explain what we see, a few exoplanets here and there, in terms of universal laws of physics that we do not see that govern those trillions of other planets we do not see. We explain the seen in terms of the unseen. But ignorance is not merely of that kind, the Socratic kind. Socrates conceded he was the wisest man in the world only insofar as he understood he knew so very little. Ignorance in this world runs deeper still. We now know, unlike Socrates, that it is woven into the very laws of physics. The laws of physics themselves bound our capacity to know in advance what is going to happen moments from now, much less in a month or more. This is not merely a problem of intractability, a fancy term describing how some systems get so complex that it is infeasible to try calculating what all the particles will do from one moment to the next. But also for any single particle, there are situations where we simply cannot predict what path it will take. I'll come back to this. And our ignorance is also born out of what we are as human beings. Creative entities. I mean that literally. We create things. Something wasn't there before, it is there now. It's not a mere recombination of existing knowledge, although it can be that too, but there is no denying people generate newness in this world. And fundamental physics, powerful though it is at prediction at times in prescribed places, it cannot predict the products of creativity. The philosopher Karl Popper and his intellectual descendant David Deutsch have written and spoken extensively on what we know about knowledge, what it is, how it is tested against reality, what works, when to move on, and the significance of that field that studies it directly, epistemology, for everything else. What you know about how you know affects your very own psychology. It underpins how science works, mathematics, history, all of our academic disciplines, and the day-to-day we encounter the world in solving our problems. In what follows, I credit both Popper and Deutsch up front for inspiring much of this, with some light embellishment for myself, as we talk about the possibility of prediction in an age that is becoming increasingly uncomfortable with uncertainty and desperate to know the future. I don't want people to be uncomfortable with uncertainty. I want them instead to relish in not seeking certainty. For to be certain, truly certain, that something is true or something must happen is dogma. And people tend to go to wars, metaphorical and real, over dogmas. Knowledge is good. Plain old, uncertain, but good explanations of this world. That's part of what we know. That's an aspect of knowledge. So as many of you already know and can guess, my area is originally physics, and physics is preeminent, shall we say, among the sciences for making highly precise predictions. That's not all it does, and we'll come back to that too. But famously, if you give me the equation and the height at which you are holding some ball, I will tell you down to the millisecond exactly when it will hit the ground when dropped. That's a prediction, and it gives rise to what has sometimes come to be called physics envy in other fields. A pejorative phrase because, for one thing, physics just is not mainly about prediction anyways. Incidentally, chemistry does just as well with predictions. Take hydrochloric acid and mix it with sodium hydroxide and you will get sodium chloride and water. But no one speaks of chemistry envy. In any case, science in the main is not about prediction, it's about explanation. This distinction matters more than most seem to understand. Most of what we are doing day to day is trying to understand, to explain, not to predict. And sometimes our explanations lead us to understanding that we cannot predict some things even in principle because of what it is we are, people, the creators of knowledge. And when in some fields we cannot make physics-like precise predictions, this is no value judgment. After all, the very thing I am talking to you about right now, epistemology, how knowledge is created, what it can do and its limitations, cannot predict anything like the content of any future explanation of what epistemology might say. But epistemology, as it is, explains quite a lot. So when I say, as I will, some things are inherently unpredictable, this does not mean they are forever incomprehensible. And ultimately, that is what we need, an understanding, a good explanation. But let us deal with prediction first, and what cannot be known as a matter of the most fundamental physics we know of to date. We have known about subatomic particles since the 1930s. Subatomic, things smaller than atoms. We can take half-silvered mirrors, called so for unsurprising reasons. They have half the silver of regular mirrors, and so instead of seeing a lovely, almost perfect reflection, what one sees is only half the light bouncing off the mirror. The rest goes through, is transmitted, as light tends to be, through glass. In fact, a half-silvered mirror is also known in some applications as one-way glass. You see it in those detective movies. It's the glass in an interrogation room, like this. The room brightly lit can be seen into, the occupants of a darkened room outside cannot be seen. Not enough light is able to get through. Now the thing about light is that it is made of packets of energy called photons, and it was photons, among other things, that gave Einstein his Nobel Prize. It wasn't relativity, it was work on the photoelectric effect, a demonstration of how light is quantized, comes in particles. He explained that. So now I'm going to tell you, using half-silvered mirrors and photons of light, why there is a kind of inherent unknowable aspect to the world at the most fundamental level known. Unknowable to a subject, to a person, an individual, certain things they cannot predict. We are able to fire single photons at half-silvered mirrors. I said before, if you just shine light at a half-silvered mirror, half of it will be reflected, half of it will be transmitted. Well, okay, let's turn down the intensity of our light beam until we have just one particle of light, a single photon travelling towards our half-silvered mirror. Does it, the very one you choose to fire now, go through the half-silvered mirror, or does it bounce off? Now there's no use saying, well, half of the time it goes through and half of the time it bounces off. 50% transmission, 50% reflection. That's true, but if you want to know about your photon, the one you are about to fire, what will it do? We literally cannot say. At heart, the laws of physics mandate subjective unpredictability. In other words, things you do not know, things you cannot predict. The laws are deterministic. It's absolutely determined that repeating the experiment over and over again, the data will converge on 50% go through and the other 50% bouncing off. And you know that these are the two options, but that is of no use if you are interested in your photon. But for example, it might determine what you will do next for whatever reason. From your point of view, you just don't know. And not only don't you know, the very laws of physics say it's impossible to know. That's baked into reality. There are many such examples, but this is just the start of it. There are some systems so simple, as we've just mentioned, single particles and little mirrors, and we cannot even know what will happen with certainty something as simple as those, whether it will bounce off or not. Now, to speak in terms of the motion of particles, when discussing the topic that I'm talking to you about right now, decision making, is to commit the fallacy of reductionism. Of course it is. Now, it's not that anything I said about particles is false or entirely irrelevant, but rather it kind of misses the point. You don't base important life decisions on whether a particle of light will bounce off a mirror or not. But we are talking, if we are talking about decision making, about guessing at the future. We want to be able to predict. So we should want to know when that's on the table and when it's not. When we make a choice, we are choosing among options. Which options? Well, the options we already know, yes, okay, that's part of it. If you're in a foreign country and they have McDonald's and KFC, you know about them, they're on the table. They're options. But also, there are options you are yet to discover, or better yet, create. And this idea of knowing and creating new knowledge is the domain of knowledge creation. And that's really where I'm going with this. So let's begin with the good news. You cannot predict the content of future knowledge. And well, isn't that just great? Is something you cannot do. If you could predict the content of the next scientific theory, well then you'd have that prediction of what's in the theory yet to be discovered, let's say next year, now. So you'd know it now. In other words, you just contradicted yourself. I mean, wouldn't every physicist love to know how to improve on Einstein? If any scientists in this world think they can predict stuff, it's physicists. So why aren't they just calculating their way to whatever might replace Einstein's general relativity? And why isn't ChatGPT for that matter? Well, again, because they cannot. We cannot predict the content of theories yet to be created. If anyone could do that, they'd already have the replacement, and presumably the Nobel Prize. Knowledge is hard won. Something remarkable goes on when creating knowledge, and it's all there in the creating part. Actual creation is going on in the minds of people, even if some try to deny this, especially with the existence of large language models, ChatGPT and its rivals, which are all the rage right now. People in the tech world and allied areas are coming to say humans are just like large language models of a kind, recombining things already stored in the brain in new ways. Sounds reasonable, but it's also false. Recombination is not creativity, however much the two at times might resemble each other. Sure, recombination can give novelty, the illusion of creativity, but taking all the information across the world and putting it into a database that exceeds the size of any database, until now mind you, and having a clever algorithm recombine that information in novel ways is impressive. Sure, super impressive and super useful, but it is not creativity. It is deriving things from that library. An infant child, on the other hand, or any person for that matter, is achieving more remarkable things by not referring to vast libraries, but rather given very scant information, scant amounts of evidence. They guess at the nature of reality with just a few tiny clues and are curious about it, prodding it, prompting it, if you will, to use the technical jargon. ChatGPT 4.0, as wonderful as it is, has an ever-demonstrated curiosity about anything. It is a perfectly obedient chatbot. I don't know if you know any real people. They aren't, in the main, perfectly obedient. So we have a chasm of difference there. Recombination of existing knowledge versus true knowledge creation. It is knowledge creation, I want to say, that underpins human decision making. Knowledge creation is what separates a person from the tools that people use, whether they be pocket calculators or large language models. But to understand knowledge creation, we need to understand knowledge. What is this thing, knowledge? Over the years, philosophers have often tried to explain some version of knowledge as being justified true belief. JTB, justified true belief. That has been said to be knowledge. Sometimes the justification is more or less strong. It's justified to some extent, people say. So it's probably justified, they say, or justified to a certain level of credibility or credence. And this level of credibility can actually be quoted in precise numerical terms. That is known as Bayesianism. Now I'm here to tell you that Bayesianism of that kind, the capacity to predict, for example, the content of future theories, is wrong, root and branch. But before we get there, we need to refute its ancestor, or older cousin perhaps, justified true belief. I can do that with a couple of examples. The first are so-called Gettier problems. They're really Gettier refutations. It's the kind of thing I used to teach when I was a teacher and I taught a subject called theory of knowledge. They made a big deal about justified true belief, and then they made a big deal about these things called Gettier problems. Here's one version of a Gettier problem, and in fact this one comes from Bertrand Russell. What time is it? Here's a clock. You look up and you see, there we have it, an old style clock. You've lost your phone, you don't wear a wristwatch, you're in the middle of London, and there it is. What time is it? What is Big Ben telling us? Well, it's daytime, so you presume midday, not midnight. So you know it's midday. But what if I told you the clock is broken and has been showing midday for the last week as it undergoes maintenance? Okay, now what if I further tell you that by a remarkable coincidence, when you do look up at it, it really is midday? Do you actually know it's midday? Well, you're not justified in thinking it's midday, right? The clock is broken after all. But it is true that it's midday, but you don't know that. So this is a problem for justified true belief. Another example, and this is the one that I like to use with my own students. Farmer Joe has a dairy farm and a large family. His favourite cow, Daisy, is a black and white beast, and he checks on her every morning to see if she is near the farmhouse or has wandered a long way off to a distant corner of the property. So he looks out his window, and sure enough, the familiar outline and unmistakable markings of Daisy confirm for him. So he now knows that Daisy is there, apparently. But here's the rub. Farmer Joe's children happen to be participating in the local pantomime that week, and little Jack is in the head and Jill is down the back inside a wonderfully well-made material replica of Daisy. Daisy is just behind them, out of sight. Now, does Farmer Joe know Daisy is nearby? Again, it's true she is, but he can't know that. He never actually saw her. So these Gettier cases are cut and dried refutations of this way of viewing knowledge as being justified true belief. But I want to take things up a notch. My own go-to example in all of this is Newtonian gravity. So Newtonian gravity is used in all sorts of ways to this day. It is used in calculating rocket trajectories. It's used in calculating tides. It's even used in calculating the position that the moon will be in as it orbits the Earth. And it's historically used in calculating the positions of all the planets in the solar system. This is Newton's so-called universal law of gravitation. Look at it. Simple, elegant, and as it turns out, completely, strictly speaking, false. First, the F stands for force, and there is no such force of gravity. If that sounds absurd to you, don't worry, I will come back and explain why. But we know all of this because, as I say, it was historically used to calculate the position of all the orbits of the planets. But there was one planet it turned out it never quite worked for: Mercury. This was a problem for Newtonian gravity. For ages in the late 19th and early 20th century, astronomers tried in vain to account for the small deviation that existed but grew worse year on year in calculating the position of Mercury. It was known as the problem of the precession of Mercury's orbit. Basically, the long axis of the orbit moved over time. Why? Well, it took the genius of Albert Einstein ultimately to solve this. He created general relativity. Created, I say, and not discovered, for reasons I'll come to as well. He created an explanation, a scientific theory that there was no force, but rather it was the curvature of space-time. That's what gravity was. His equation looks, well, shall we say, somewhat more complicated than Newton's. And it is. But it allows for more precise predictions. It gets Mercury's orbit correct. But Newton's doesn't. So that rules out Newtonian gravity in favour of general relativity. Newton's theory is falsified by experiment. Yes, Karl Popper was right. This is how it works. You take two theories, you perform an experiment, and you rule out one. That's called a crucial test. Yes, the test can go wrong. Karl Popper was right about that too. Just for example, in 2011, at the Large Hadron Collider, the particle accelerator at CERN in Switzerland apparently found particles called neutrinos were observed by instruments travelling faster than the speed of light. At least, that's apparently what was measured. This violated Einstein's theory. People said at the time, in breathless headlines, Einstein proved wrong. Of course, no such thing had happened. There was no alternative theory against which Einstein's theory could be proved wrong. What would we replace it with? Not Newton's, that was already known to be wrong. And anyway, it wasn't just the motion of Mercury, but Eddington's experiment where light was bent during an eclipse by just the right amount according to Einstein's theory and not Newton's. And there was more, but we don't need to be further convinced. In the Large Hadron Collider experiment, we simply did not have two theories to decide between. There's a genuine decision, right? Which of these two theories? Well, at the time of this neutrino experiment, we only had one, and as it turned out, the experiment was flawed. It was the experiment that had a problem. We had a problem situation of this observation of the neutrinos apparently not fitting with what Einstein's relativity said. That was a problem, but it didn't rule out relativity. We just didn't know whether it was Einstein's theory that was flawed or whether it was the experiment that was flawed. Popper understood this was a possibility. It's come to be known as the Duhem-Quine hypothesis. Either the explanation of the theory is wrong or the explanation of the experiment is wrong. Well, in this case, at the Large Hadron Collider, it was the experiment that was wrong. They misconnected a cable, if you can believe it, and so the calculations were incorrect. It turned out, after checking, that neutrinos did indeed travel slower, if only ever so slightly slower, than photons, particles of light. So Einstein's theory not only makes more precise predictions, that's one thing, but it does another more important thing that science and all knowledge generally does. It explains stuff. It explains what exists and what it does. So in the case of Einstein's theory of general relativity, it explains that what exists is a fabric of space-time. And what it does is bend and weave and curve whenever there is mass present. The mass moves according to where space bends. Space tells matter how to move, matter tells space how to curve. That was the way the great general relativist John Wheeler explained things. There is no force of gravity, as no force is needed. Technically these days anyway in science, a force is mediated by a particle called a boson, but there is no boson here. No particle is needed to achieve this, despite what some particle physicists hope will be the case, the discovery of a so-called graviton, the particle of gravity that mediates gravity. But we have no reason to think that that exists yet. So why does space curve in the presence of mass? And why does mass move in the presence of curved space? Well, as Wittgenstein said, and I'm no great fan of Ludwig Wittgenstein, but he did say on other matters, you get to a point where our spade is turned. In other words, at the moment, we don't have a deeper theory. We can dig no deeper. Our spade is turned. The theory is silent on that. We need a better theory that we can test. But in any case, Einstein's theory is the best explanation thus far. But it is not complete. It does not mesh well with quantum theory, for one thing, for reasons I won't go into right now. See some of my other episodes on that, or just Google it. Why don't general relativity and quantum theory agree with one another? What is the problem with uniting general relativity and quantum theory? It's a well-known issue in physics. But anyway, this is why Einstein's theory of gravity was a genuine act of creation. As a composer would create music. It's not a discovery, or more precisely, it creates knowledge, general relativity, about something to be ever more precisely discovered. The phenomenon of gravity. Both Einstein and Newton, not to mention their predecessors back to Galileo and Aristotle, agreed gravity exists. They just disagreed on what it was. They had to create knowledge, and someone will create better knowledge. We make objective progress, and we know this because our predictions become ever more precise. We say, look, the planet is there where I calculated, and there it is, more or less. So come to today, and as I said, Newton's law of gravity here says there is a force, but there is no force. And very strictly speaking, it gets the prediction wrong. All the time, you look precisely enough. It's not as bad as Ptolemy and earlier physicists before Newton, but it is wrong. And looked at close enough, it is completely wrong. So it's not true. And so therefore, nothing about Newton's theory can justify it as true. So no one should believe it. But it does constitute knowledge. I know it. Any physics student knows it. Now you know it too if you didn't know it before. It's not justified, it's not true, so don't believe it. Everything about knowledge is justified true belief is false. So why does it count as knowledge? I said I'd come back to this. It's knowledge because it does solve a problem. Have a problem of calculating tides? Use Newton. Have a problem of calculating how long it will take for some rock to fall to Earth when you drop it? Use Newton. Want to calculate the trajectory of a rocket? Use Newton. No one is tempted to use Einstein's equations in most of these situations because although they technically could, it's too laborious. And the difference between Einstein and Newton in these situations is only found in the 5th decimal place or something like that. In other words, it makes no practical difference. Unless the gravity is strong, like in cases where a planet is super close to its host star, as Mercury is to the Sun. So what is knowledge? Well, knowledge is certainly important. It's information, after all, that helps us to make decisions. It is literally what helps us choose between things like Newtonian gravity and Einstein's relativity. So knowledge solves a problem. Because it solves a problem, it's useful information. And because it's useful, it tends to get copied. As David Deutsch eloquently, poetically put it, it is information that once instantiated in a physical substrate tends to cause itself to remain so. Or as Chiara Mailetto, a researcher into constructive theory, has said succinctly, it is resilient information. Okay, so now I've mentioned information several times, and implied knowledge is a kind of information. So then, what is information? Well, that's a physics question, so let's avoid it for now. See, for example, the work of Chiara Mailetto in The Science of Can and Can't, where she goes into great detail about what information happens to be. I'm going to stick to what concerns me now, about information and decisions. Information might be useful, that's knowledge, or it could be useless. If it turns out, mind you, to be useless eventually, then it gets discarded. It's the errors. So a composer fills up their waste paper basket with all the attempts that do not meet their criteria for what is harmonious or melodic, let's say. That gives them some information about what does not work. Einstein didn't get general relativity right on the first go. He got information from his mistakes. He guessed at what was really going on, as we all do all of the time, and rather most of the time, no surprise, we're wrong. We must decide between what is useless information and what is actual objective knowledge, by which I mean, in many cases, a good explanation. And by good explanation, I mean hard to vary. And that means every part of the explanation has causal power and cannot be changed even slightly without ruining the explanation. Our explanation, for example, of what matter is comes down to atoms, and the atoms themselves are constituted of smaller particles still. For example, the electron. The electron is an essential part of the explanation, exceedingly hard to vary. For example, it has a particular mass and a particular charge. We cannot arbitrarily change, swap, or decide some other particle will just as well fulfill that role. Indeed, the existence of the electron is forced upon us by this grand explanation, which actually has a name in physics, the standard model of particle physics. By the way, I did say I would come back to Bayesianism. This is an alternative epistemology that says we can assign probabilities to the options before us and calculate which is most likely. Likely to be true, presumably. But in fact, as we have already seen, it's rare to have many options on the table, much less be able to assign probabilities to them. In the debate over gravity between Newton's theory and Einstein's, no one was making actual bets with literal probabilities. They were performing experiments which were decisive, crucial tests. Those tests simply ruled out Newton's theory from being true. Now, whatever the probability was of it being true is now known in retrospect. It's zero. But as it turns out, it was always zero. It never was true. Yes, it contains some truth, but we do not know how to quantify truth. Newton's theory was just saying something qualitatively right about reality. There is this thing called gravity that exists between masses, and so long as those masses are small and separated by sufficient distance, then Newton's formula F equals g m1 m2 over r squared approximately calculates the magnitude of that influence. But it is, and always was, strictly false. And so too with general relativity. We just don't know how it's false yet, but epistemologically, as I've already said, we know there must be a flaw with it. It's not complete. It doesn't mesh well with our other grand theory of physics, fundamental physics, quantum theory. But in the case of general relativity and Newtonian gravity, both of them have been good explanations, and are good explanations given a context. They are hard to vary. Newton's here is an inverse square law. You can't just change it to an inverse cubed law. That doesn't work. It's hard to change it while still doing what you want it to do. Explain the world to some extent and get the predictions approximately right. And the only way, as I say, to get the predictions right is to dump that particular formula and that particular theory of gravity altogether in favour of Einstein's. An even harder to vary explanation. The Enlightenment itself, which we are still living through, is defined by a civilization's search for good, hard to vary, explanations. A tradition of criticism. Criticism aimed at finding flaws with existing knowledge, with the further aim of finding something better, improving things. Science and experimental testability is just a special case. It's a special kind of criticism that applies in science to scientific theories. And when a scientific theory is testable, that's a necessary but not sufficient criterion for a theory to be scientific. See, for example, David Deutsch's grass cure for the common cold thought experiment from his book, The Fabric of Reality, or the Naval podcast where I explain it here. That thought experiment illustrates that a scientific theory being testable makes it especially hard to vary. After all, the precise predictions of what happens in the physical world according to physics, or chemistry if you like, are exceedingly hard to vary. That makes the scientific theory of any phenomenon typically very good indeed. So then what's an easy to vary explanation? Magic. Anytime something happens anywhere for which you do not know the answer, just say, I explain it by magic. Magic did that thing. Don't know how thunderstorms work? Lightning is magic. It's an all-purpose explanation that can be varied from phenomena to phenomena, never actually explaining anything because ultimately it's contentless. We could swap out magic for miracle or sorcery, easily varying the word we use to describe such supernatural forces at work, manipulating the physical world behind the scenes, as it were. It is for this reason we say all appeals to the supernatural in this way are bad explanations. And I mean this in a technical sense. I do not just mean false, although they will be that too. I mean bad, too easily varied. If you're happy with one supernatural explanation, say the god of thunder Thor causes electrical storms, then why would you be dissatisfied with a similar explanation that not the Norse god, but rather the Hindu god Indra caused the storm? Incidentally, Indra is the god of thunder in Hindu. Gods of thunder are easy to vary. Maybe they're all the same thing. But whatever the case, magic or miracles did it, it's no explanation. We want to know how and why, and more besides, we want to know how to test those explanations, how to sift, as it were, the good explanations from the not so good. And that is along this hard to vary criterion. Now, there are very rare cases where we have two good explanations to choose from, especially in science, as we have already mentioned. Sometimes in real life we do as well. What to have for dinner? All options might seem good, sometimes none do. And the decisions we have available to us in those cases are actually infinite. Why infinite? Because we are not machines, we are people, and people are not mechanisms just following deterministic laws. We are not dumb computers, we are something more. We are creation engines. We create. We bring new things into the world, new options that were not there before. Before anyone discovered nuclear physics, no one could choose to have nuclear energy as an option on the table when it comes to energy production. There is a big debate agitating the political class in Australia right now. Should we build a nuclear reactor or not? Never mind the answer. For our purposes here, the fact that we can even ask the question is proof positive some knowledge was literally created at some point in the past. It is a question that could not have been asked in 1900. So when we make a decision, we are choosing not only among options we already know, but among options we also create, often on the spot. And we are choosing among the various explanations as to why we are doing what we do. Again, I have to emphasize, this choice to do what we do often in real life, indeed usually, means rejecting all known explanations, everything known to that point and their associated explanations, and creating something new. The great mystery at the heart of what it is to be a person is we do not know in fine-grained detail how this works. We know we do it, we create, we especially create explanations that put new options on the table, but we do not know how we do it. Objectively, in terms of science, it is a mystery, and the mystery that needs to be solved before we have artificial general intelligence, a computer system that would be a person. But also subjectively, you speak a sentence and you do not know how you get to the end of it. The words just flow, an idea pops into your head. That's you doing that. You had the idea, you created it. But how? Well, we don't know. Oh sure, we can use words like the subconscious or the great unconscious or instinct or perception, nurture and nature, but these are just to label yet other partial aspects of the central mystery. Our creative capacity to solve problems and make progress and build things like, well, all of this around you, wherever you happen to be, and on whatever device you happen to be watching this on or listening to this on. And our choice to make things better, or fail to make that choice at times, comes down to that thing which we all share. The capacity to create something new, to have an idea. This mystery may one day be solved, but it has not been solved yet. Although some think we are indeed on the way to solving it, that the superintelligence is around the corner, after all, isn't ChatGPT a sign of this? The rather abrupt appearance of the so-called large language model on the scene was a surprise to many. That remarkable piece of software I talked about earlier manages to achieve a level of language ability in an otherwise dumb computer few saw coming so soon. One moment it was obvious that machines were not able to pass the Turing test, and the next moment, well, there it was. ChatGPT 4 and its descendants and offshoots are able to have quite passable conversations with people. So, okay, it's not perfect. We can still tell, but it's a great leap upon what existed before. Now, what explains this remarkable increase in functionality? Is it about to achieve what we have? Is it a stepping stone on the road to becoming an actual, thinking, creative person? There are two parts to a large language model I want to highlight. First is the large part. ChatGPT 4.0 has loaded into it the largest library of information ever gathered together in one place on the planet. It is that huge. Almost all the books, the translations, the corpus of the existing internet and other libraries, it was trained on all of these, the entirety almost on the works of human civilization assembled over thousands of years. And it can, at near the speed of light, access it all from hard drives. And well, that's the large part of the LLM. So the second part of all that is the model. The model is able to recombine all that information in ways people may never have seen before. But that is from a God's eye perspective, so to speak, what it is doing, taking a library larger than any other that has existed before, and it is using an algorithm. This is known as the transformer architecture, for what it's worth. I won't attempt an explanation of that now. References here on my website for that. So the algorithm takes all of that information and recombines it all to provide useful answers in, as I say, and as I will emphasize again, an obedient way to prompts given by people. It does not self-prompt, it does not have interests, it's not creating new explanations, even if it does generate novelty. So then what's the difference? Well, novelty is just something that has not been seen before. And if your special language calculator has access to the entire corpus, more or less, of human knowledge and clever rules about how to recombine it in a sensible way, you will get novelty. Things not seen before. A new limerick, let's say, a new script for a never before made episode of Seinfeld. But as I've already observed, recombination is not creativity, because you are drawing from inside a finite library, no matter how large it is. But we people, we can step outside of the library. We can think of something new that is not a mere recombination, but a creation. It may also involve recombination, but it has something else, some other spark of originality, a true innovation. This is what people can do. They can disobey. They can look at all the otherwise good explanations and reject all of them and say, no, I will make something better. And why? Well, just for the fun of it might be one reason, but another could be what is animating me here and now. Decision making. What should I do next? How can I know what will work or what might fail? But also because, well, we want to solve our problems. All life is problem solving in the hope we can make the future a better place. So it's true, we do want to predict, we want to know what the future holds. These days we even have whole professions devoted to it. Futurists, they are sometimes called, or forecasters, or sometimes super forecasters. They're all claiming to know the future. Can they? Well, if they have a good explanation, they might be able to. A physicist, as I've already mentioned, can drop something out of a window and calculate to a very high precision exactly how long it will take for that object to hit the ground, given the height of the fall. But here's the rub. This must ignore anything a human might do to intervene. If I am on level 8 of an apartment block and I drop a ball down to the ground floor, I might have a computer help me with the calculations by correcting for air resistance and the shape of the ball and so on, and it might well lead to the prediction that the ball will hit the ground exactly 2.21 seconds after I let it go. But all that precision and the very laws of physics are never going to give me the correct answer if the truth is that on level 4, Jeremy reaches his hand out the window and catches the ball before it ever hits the ground. The actions of a human being, the inherently unpredictable actions of a person, have intervened and changed the outcome. And that is so for so simple a system as balls falling to the ground. This leads to that great dichotomy in forecasting. The distinction between prediction and prophecy I mentioned earlier. And if we want to make rational decisions, we should understand how this distinction plays out. I have mentioned prediction a lot already, and predictions are indeed possible, as I have said. The physical sciences are wonderful with prediction. Medicine is becoming increasingly good at predicting. Take this antibiotic, your infection will be cured at some point in the future. Take this vaccine and you will be less likely to suffer symptoms and so on. Predictions are possible, but long term, across civilizations, they have become increasingly difficult, intractable, and even inherently impossible. Because again, the one thing we cannot predict is the growth of knowledge. We cannot predict the content of our future explanations. Those things yet to be created. Trying to predict what the population of planet Earth will be in 100 years assumes we know what choices people will make in 5 years, then in 50, and so on. What life extension technologies might be invented, what natural disasters might occur, what cultural shifts might happen, how trends might change. In other words, a forecast about the future population of the globe is not a prediction. It is a prophecy. It cannot be known because it depends on what problems people are yet to encounter. That's very unknown. And what solutions they might propose to overcome those unknown problems, well, that's doubly unknown. But people have a deep need, a hunger for knowing the future, because they want to decide what to do today so they can best be prepared for tomorrow, or next year, or 10 years or more from now. And there are all too many people with a vested interest in telling you they know the future. So we have new ideologies arising, and they share two things in common. The first is they claim to be predicting the future, and the second is it won't be good. Some claim artificial intelligence today portends the end times, that the AI will become super intelligent and regard us as a threat and kill us all. Those are AI doomers. Some claim that the next virus to escape a laboratory or a wet market will be impervious to our attempts to curtail it, and the population will collapse under the pressure of a spreading pathogen. Those are disease doomers. In my original area of interest, astronomy, it's all manner of things that are going to kill you. We can already point to asteroids and comets that have hit our planet over the course of its 4.5 billion year history that could strike Earth and could wipe out almost all species. It's coming again, we are warned. Cosmological doomers. Or the big one, the earthquake to end all earthquakes. Or the supervolcano lurking underneath Yellowstone National Park. So certain seismologists and geologists want to tell us. Geological doomers. And of course, some are concerned that we will do nothing to change the course of climate change. Ecological doomers. Some are concerned our political institutions are going awry too fast under the sway of social media influence. Civilizational doomers. Elon Musk and others are worried about population collapse due to declining birth rates today. We'll be extinct because people aren't making enough babies. Baby doomers. Nuclear apocalypse, famine, pestilence, locusts. The list is much longer than I can possibly picture here. It's a horror story out there if you pay too close attention to some of these people. People who guess at the future are very, very good at imagining the problems we have and are going to have. What they are rather worse at imagining is the solutions to those problems. And yet, we are problem solvers. It's what we do as creators. And the solutions are in fact the hardest part. The solutions are the scientific theories, among other things, and the great feats of engineering. General relativity was a solution that solved the problem of why Mercury orbited the Sun in just the way it did, among other things. Spotting the problem, any old astronomer could do that. Any astronomer could point to the problem and understand it. But it took Einstein to create the solution. And these days, everyone's mobile phone equipped with Google Maps harnesses the general relativistic equations of Einstein daily, literally saving lives when people in the past would have gotten hopelessly lost in the wilderness. And so, doomers are not predicting, but prophesying. They are claiming to know the content of future explanations, and in the main they are saying, no solution will come in time. We are doomed. So, make your decisions now, given the worst is going to happen. The AI will take over. You will get a deadly virus. The sea levels will rise and democracies will fall everywhere. How can they possibly know any of this? They cannot. They do not. It's a living though, talking about the future death of civilization. There's $1 in it. Now I do concede, on the other hand, there is an equal and opposite irrational reaction to this. There are such people who say technology will inevitably save us, that the arrow of progress only ever points in one direction. Well, that's false too. It's not as bad because it's optimistic at least, but it is naive. There is no inevitability in things getting better, in our making progress. Civilizations fail and fail all the time, and that could be the case for ours unless we continue to make the right choice. We have to continue to choose to. We have to continue to make the right choice. So here's a distinction for you. A prediction follows from a good explanation. It is a logical consequence of a good explanation. It says, ignoring people intervening, such as Jeremy reaching out the window to catch my ball before it hits the ground, or ignoring people creating the knowledge to reverse climate change and so on, this is what will happen, or would happen, and explicitly saying, ignoring knowledge creation. Okay, that's a prediction. But a prophecy? A prophecy does the same thing, but hides the ball on human creativity. It says, here's what's going to happen inevitably. No matter what people do, the worst is going to happen. Prophets tend in the direction of pessimism precisely because imagining problems is easy, but guessing the solutions is, relatively speaking, much more difficult, much harder. But solving problems is what we do in the long run. We, the descendants of the Enlightenment, I mean. We who inherit what David Deutsch calls a tradition of criticism. We critique our best ideas in the hope of moving forward, and ideas come in many sorts, as I've explained before in this podcast, for example, with a focus on the conscious contents of our minds, not the unconscious, which are substantial too. But criticism is how we improve and how we want to avoid becoming prophets in our own lives and in public. We want to make rational decisions that are informed by good predictions if and when they are available. Often they are not. Often we are engaging in pure guesswork. So is there any way we can make better guesses? One thing I want to push back on, and it shouldn't be heresy to say, is that when making decisions we should weigh the evidence. Ever watched a police or courtroom drama? Ever been in a courtroom and listened to the way those involved in the legal system speak? How does the judge make their decisions? What do they say explicitly about their process? They say they weigh the evidence. They also say, on the balance of probabilities. But this entire way of thinking and speaking is not and cannot be the way anyone ever actually makes decisions. For one thing, how much does evidence weigh? I'm not trying to be clever. If this is just a metaphor, then a metaphor for what? So the trope goes, there is evidence over here supporting theory A, and then there is evidence over there supporting theory B. But in truth, the truth is that in any legal case, say a murder, it's rare for there to be many theories. Either you've got one very good suspect or you have none. A single theory or no theory. If you have good detectives and good forensic work, you may just, if you are lucky, form a single, hard-to-vary explanation. And the judge can then decide that such an explanation explains the evidence or not. He does not weigh the evidence. The evidence is the very thing to be explained. Why were the defendant's fingerprints on the knife which had the blood of the victim? The theory that the defendant killed the victim with the knife explains a lot. And absent any other better explanation, that defendant is now going to be a convicted murderer. The judge does not weigh the evidence, they explain it. Who cares about these semantics though? Well, the thing is, it's not just semantics. If we do not know the function of evidence and the function of explanations, then we are liable to fall into irrationalities when making decisions. And who wants to be irrational? So let's return to probabilities once again. The balance of probabilities. We hear that quite a lot too. So let's say we've got Alice and Bob and both are suspects in a murder. Alice had motive, but Bob, he had the means and the opportunity. After considering all the evidence, Judge Judith says that on the balance of probabilities, Alice is the murderer. But how did she, the judge, balance these probabilities? Seriously, who told her what the probability was? Is it just a manner of speaking? Well, if it's just a manner of speaking and is synonymous with, given the evidence, the only known explanation that fits the facts is that Alice is the murderer, then very well. But again, we have to be careful. Whenever you are told that something is probably the case, ask what that probability is. And then the really hard question is, how do they know? All the rage right now, as I say, is Bayesianism. And this is a particular hobby horse of mine. This is supposed to be the mathematically sophisticated way to make decisions. We actually have a formula. Here it is, Bayes' theorem for making decisions. But these variables here, they need to be replaced by numbers, actual probabilities. But how can we know what the probabilities are? If I roll dice, then to a first approximation, namely assuming an ideal die and no real physical die is an actual ideal in the mathematical sense, we can say there is a 1 in 6 chance of rolling a 3 or a 2 or any other number. And how can we say that? Because we know the odds going in. Importantly, we know that denominator. There are only 6 numbers. We say a priori, our prior probability, that is, absent knowing anything else in the universe, we know that. We know that dice have 6 sides, each with a different number and each equally likely to come up. Our PA, in other words, in our theorem is 1/6, our prior probability. The denominator is 6 because we know that a fair regular die has 6 sides. But now, imagine when you do not know the denominator. What do? What is the probability of an earthquake tomorrow in Auckland? Even if we can look at historic data, past trends do not indicate future performance or future movements of the earth, as the case may be. How can we make decisions about what to do when the future is inherently uncertain? Well, not on the basis of probability, which is unknown, but based upon good explanations. Earthquakes have happened, can happen, and will happen. We just do not know when. It is an active area of research in the community of seismologists, and not knowing when is no argument for assuming they will not happen tomorrow. So build your structures as if the earthquake will hit tomorrow in earthquake-prone areas. That way there is no need to concern yourself with probability or Bayesian inference. You just rely on what you know to guard against, to the best extent possible, your ignorance of the future. And besides, things do not probably happen anyways. They either happen or they do not happen. This renders the entire Bayesian approach misguided from the start fundamentally. We want to know, want to have a good explanation if something will happen or not. And if we do not know, if we lack a good explanation, we should admit that. We should say we do not know. That is the rational thing. Hence this maxim. It is simply an appeal to modesty in the face of the unknown. Now, many decisions we make each and every day aren't quite so life and death as preparing for natural disasters, it must be admitted, but they do affect and involve other people. When making a decision, what you want, ideally, is to be logical. Make a logical decision. But don't you also want to be fair? Who wants to be illogical and unfair? Well, I'm here to tell you it is impossible to be both fair and logical simultaneously when making decisions for groups of people. And this strange but very deep and true fact about so-called rational choice theory has wide-ranging consequences. It is known as Arrow's theorem, named for Kenneth Arrow. Here he is, and putting things in rough plain English, it says that there exists a proof that it is impossible to simultaneously be both logical and fair when choosing among options. Now, to fully explain this would take a lecture in itself, but let me give the abbreviated version, which I am borrowing from The Beginning of Infinity by David Deutsch. The United States has a Congress, and that Congress has a certain number of members, 435 in the House of Representatives. How many members does California have? Well, it's got 52. Why? Well, the law says that the politicians there are allocated from the states according to and in proportion to the population of those states. That's what's fair. So California has far more Congress people than Rhode Island, for example. But how many more? Well, to make it perfectly fair, the number of representatives should be exactly the proportion in the Congress that there are people in California as compared to the population of the United States. The problem with this is, well, you don't ever get whole numbers. California is entitled to 51.7 representatives, to be fair, for argument's sake. But there is no such thing as 0.7 of a representative. So what do? Well, we round. That seems right. Why not? Well, now you're illogical because you round up to 52 and you round for all the other states as well. And now you don't have what you wanted. A 435-seat House of Representatives. So then why not just change that new number that you get after the rounding? Well, if you do that, it now won't be fair because the Congress will now be that much larger or smaller, and it won't be fair for California or any other state because now they do not represent 12% or whatever of the Congress, but something less. It's unfair. You cannot both be fair and logical, and as I say, there is a proof of why this always is the case. Now, in the culture wars right now, one side does make the point that equality of outcome just is not possible if you give people equal opportunity. But no one ever makes the point that really, if you are being logical, and you want to be logical by having equality of opportunity, we cannot have equality of outcome or fairness of outcome. As I say, there is a mathematical proof of this, but no one ever mentions that. I guess it's not expedient to start talking mathematical theorems in political debates, but why not? But what do we do then if we cannot be simultaneously logical and fair? What do we do? Well, we have to create some solution. And they do. And it's not perfect, of course, because perfection here, perfect fairness and perfect mathematical logic cannot both occur simultaneously. This just shows how decisions are not a mechanistic, just follow the logic, wind the crank of rationality kind of thing, and generate your decision or your prediction out the other side. We must problem solve in the main, not choose between existing options as Bayesianism implies we do. Rational decision making is not a matter of weighing the evidence or knowing the future. We cannot know the future, but we can create it. Decision making is not about calculating the probabilities. When was the last time you took out a calculator to calculate the prior probability of any major life decision, or any decision at all for that matter? You don't. Again, decision making is choice creation. When people decide or make a decision, the common sense but false idea is that they decide among the options they know. This, so we are told, is by weighing the evidence or on the balance of probabilities, or even simply refuting all but one idea, or so we are told. All this is totally wrong or misleading to some extent. To decide, one chooses, but not typically among the options already known, things already on the table, even if this occurs sometimes. But often we are dissatisfied with everything on offer to some extent. So the solution to all this? We create a new option. And that one, by our own lights, is better than all the others we knew about. We created something new and chose it. That is rational choice theory. That is decision making. So rational decision making is a matter of creating and understanding, or indeed creating an understanding, and that means having an explanation. Ideally, a good explanation, but this does not mean it must be true. It just means good to you, by your own lights. You're choosing this and not that because you can, to your satisfaction in your mind, say that you have indeed considered the options and ruled them out decisively. You've refuted them and only one remains, the one you act upon. That's your choice. It's the only rational thing left to do. So you create the choices you make. But you don't yet know what decisions you will make yet, given choices you are yet to create. So you can't predict the future. And that's just you in your own mind, predicting your own behavior. That thing which you know better than anyone else, your own mind. So what hope do you have predicting what others will choose to create, let alone what civilization will? Until next time, bye-bye.